Okay, guys, so for this section, we're going to do it part of it today, and then we'll finish the other part of it tomorrow. But we are finding the first part of this, girls, the first part of this we actually know how to do, bits and pieces of it. So we're going to fly through like the first couple slides, okay? Do you know how to find the number of solutions, zeros, answers? Do you know how many there's going to be by looking at the problem? Yeah, the highest exponent, right? Look at that. You already know the first learning target. And then we're going to find the zeros, which if it factors, we know how to do that, right? But if it doesn't factor, quadratic formula only works if it's a degree of 2. So if it doesn't factor and it's not quadratic, you need another option, which is what we're going to work on today. Okay, so the fundamental theorem of algebra. So all kinds of info up there. It sounds all complicated. You already know this. How many answers does this one have? Good job. How many answers does that one have? Great. That's the fundamental theorem of algebra. Moving on. All right. What does it mean when the graph looks like that? All right. It is negative. Oh, hold on.
It's a line.
Thank you. Okay. All right. So, okay, we know it's negative. But what's it mean? Do you see how it goes up and like bounces? Very good. Well, the zeros technically are answers, right? It's another name for those. But yeah, it crossed that's at 1. So that means x equals 1 and 1. Right? If it bounces, that answer shows up twice. It could be 4 times. But I know if it's like a degree of 3, it's not going to be. Yeah, I mean, we can use some common sense on that one too. But good. We already knew this, right? If it bounces, the answer shows up twice or 4 times or 6 times or whatever. Okay? All right, so here we go. Here's the problem. Factoring some polynomials can be difficult, right? If sum of difference of cubes, grouping, factoring like quadratics, the quartics, of all that stuff that we know if it doesn't work. So, Izzy, put your phone away. So, solution, so we need to find at least one factor, and then we can use it to break it down. So I told you that last section on like synthetic and long division, that was our stepping stone into like actually solving, which we're going to use that today. So what we're going to do, right, so the last one factor was given and we were able to finish factoring afterwards. None of them are given to us, but can you find answers on the graphing calculator? If you graph it, how do I know what the answers are? Where it hits the x-axis. Those are all your answers. Okay, so then it's just like last section. If I can find one, then I can do synthetic and I can go from there. So, this beautiful thing. When I used to teach this in Finley, I taught an advanced algebra class, advanced algebra 2. I made them do this part. I'm not making you guys, okay? But it doesn't mean it doesn't have its place. It's called the rational root theorem. It can give you a list of possible answers. Possible answers. But it doesn't mean they're all answers, okay? I do want to kind of explain it to you real quick, and I'll show you in a little bit kind of what exactly it is. Because while I still use technology when I'm solving these, in my mind is this, and it helps me kind of figure out some of my answers a little faster. Okay? What this is, you make like a PQ list, and you do your P's over your Q's, and you make a fraction, and then it gives you all the possible answers. And I'll show you what that is. But what you would do then, once you have all of these possibilities, then you would have to use synthetic with each possibility until you can find one that gives you a remainder of 0, which means it would be a factor. It is a lot of work. But could you do it? Yeah. And that was how they used to do it before you had graphing calculators where you could actually graph things. Yeah. Yeah, pretty much. All right, and I'll show you what that looks like in just a little bit, though. All right, so let's go ahead and find, it says the rational zeros, okay? On your test, it'll just say find the zeros. So finding the zeros means just find the answers. I want you to solve it. That's what it means. So first, we're going to graph it. Because right now, if I would give you that problem, and if I asked you to factor it to solve it, how many terms are there? There's 5 terms. Have we ever factored something with 5 terms? No, we haven't. Okay? So we don't have an option to factor. So we have to use some other method. So we're going to use the graphing calculator. How many answers will this problem have? It's going to have 4. Now, if I can get this problem down to at least quadratic, could I then solve it from there? I could either factor it, square root method, quadratic formula, complete the square if you really want to. I won't. Okay, but those are options. So we're trying to always turn every problem down to quadratic. That is our goal. If I can get it to linear, it's even easier, but if at least quadratic, I can solve. So let's go ahead and graph this. I'm going to be jumping back and forth here. So we're going to go ahead and graph this problem. Do you remember how to graph? Good. Y equals, we're going to type it in here. So x to the 4th. And don't forget to pop that cursor down so you don't type everything as an exponent. I've done that. Makes really weird graphs. All right, minus x cubed plus x squared minus 3x minus 6. Okay, and then we hit graph. Now, for the purposes of what we're doing in class and what I'm testing you on, I will try to make sure everything fits in the standard viewing window. I don't want half the trouble to be that you just can't see it. Okay? So don't feel like you need to move your windows left, right, up, down, anything like that. I will try to make sure I give you problems where they stay in the window. Okay? So where does it cross the x-axis? -1 and 2. Now, is it possible that it looks like it crosses, but it really doesn't at that pretty answer? It's possible. How can I confirm that that really does cross there? The table. So remember your table's right above graph. So you have to hit second, graph, pull up your table. Now you told me -1 and 2. So -1, 0. That means it fell exactly on the line. That's where we wanted it. And 2, 0. So if the y value is a 0, those are good answers. That's what it means to find the zeros. It's because your y value is 0. Okay? So that confirms that it does indeed cross at -1 and 2. I want you to get in the habit of just double checking. Sometimes you're like, oh yeah, it crossed beautifully. And then you do synthetic and you're like, well, that didn't work. Then if you look at the table, it really didn't. Okay? So we just want to make sure we're careful on that. All right, so -1 and 2. All right, so the nice zeros are -1, 2. All right, now we're going to use synthetic division to turn this into quadratic. Okay, we like synthetic, right? So is anything missing? Nope, so we'll set it up. So 1, -1, 1, -3, -6. Now I have 2 nice answers, right? We always divide by what x equals. X equals -1 and 2. Does it matter which one I use first? It doesn't matter at all. So I'm going to go ahead with -1. Let's drop that first one down. And let's do our synthetic. So -1 times 1, -1 plus -1, multiply, +2, and then add, multiply, -3. And then I add, and I get the -6. And then multiply, +6, add, 0. Now, if you go through synthetic and you don't get a 0 at the end, what's that mean? Either it's really not an answer or you messed up on your synthetic. If you double check that table and it showed you it was a 0, then your synthetic's wrong somewhere. Go back and double check your math, okay? Now, right now, where am I at? If I would put my variables back in, this one would be an x cubed. Right, because it was a 4th, I did synthetic once, I'm down to x cubed. But I need them to be x squared. Can I go again? Yeah, I sure can. Let me move this so we can see it better. Yeah, so I'm just going to go synthetic again, right underneath here. I'm lazy, right? I don't want to rewrite stuff. This time I'm going to do synthetic with my other answer, which was a 2. Okay, same thing. I'm going to drop that first number down, and I'm going to do synthetic again. So multiply, it's 2, add, 0, multiply, that was the hard math right there, And then I add. That's where most mistakes come from, is those zeros. Multiply. Add. And do I have to keep going with the zeros? No, I don't really have to. All right. So now we're ready to put our x's back in. Bless you. So if it started x to the fourth, and I did synthetic twice, I'm now down to an x squared. So x squared plus 0x plus 3, and that's no remainder. Good? Now, I like to put my equal 0 in there, right? Because I'm lazy, so I'm going to utilize that 0 sitting there. And we have to try to solve this. Now, is there something sitting there that I can kind of ignore? Yeah, that 0x, he honestly just gets in my way. So let's ignore him for a minute. And I have x squared plus 3 equals 0. Good. So x squared equals negative 3. Square root of both sides. So x equals I radical 3. So if I asked you to list for me, what were all 4 answers? What were they? Do I have 4 answers? Yeah. So negative 1, 2, and plus or minus I radical 3. Now, what do you know about answers that have an I in them in the graph? They don't cross the x-axis. Go back to your graph really quick. I'm losing things on my board here. So if I look back at the graph, how many times did it cross the x-axis? Only twice. And I knew it should have had 4 answers. It meant that the imaginary ones have to be the other 2. Now, do imaginary answers always come in pairs? They're always plus or minus. Imaginaries come from taking the square root of something, of a negative, right? So imaginaries always are plus minus. So they always come in pairs. That's important for tomorrow's part of this lesson, okay? Imaginaries always come in pairs. So it makes sense. If I see 2 and I know I should have 4 answers, the other 2 must be imaginary. All right, so we graph on this one. What in the world? Make sure you didn't type everything as an exponent. Try to get in the habit of looking at that prior to there we go. Plus. Go back to where you typed it in. You probably typed something in wrong. Every time I hit that plus sign, it puts a dot on there. My goodness, it takes way longer to type it up here than it does on an actual calculator. Okay. So your graph, wait for it. Oh, that's pretty. Well, all right. Isn't that great? That's amazing. Amazing. All right. Well, let's talk about a few things. So if we look at the problem, there we go. How many answers should I have? I should have 4. How many times did it cross my x-axis? So what's that mean about possibly the other 2? They're probably 2 imaginary. Okay. So do we have any nice ones? Negative 2? So again, if I look back at the table, second graph, pull up the table. Yep, negative 2 looks nice. Now wait a minute. Okay, so that means there's only one pretty answer. That means the other one's probably a fraction. Okay, well let's take care of this first. Right, so I know, what'd you say, negative 2? So I don't want to lose track of that one. Now, can I find the point on there? Can the calculator calculate it for me? Right, it can. You just have to know how. All right, I don't think we've done this in here yet, have we? All right, so what we're going to do is we are going to get the calculator to tell us what that is. It crossed, so it's a real answer. It's not imaginary. I'm not going to take the cursor over because the cursor will like kind of jump and hop and skip, so it's not going to always do what I want it to. So what we need to do is we can get it to do it. See the calculate menu up here? Right above trace. So hit second trace. And it's like, what do you want to calculate? What do you think it is? The 0. Yeah, so choose 0 or option 2. All right, now the calculator needs a little direction. It's not as intuitive as we'd like it to be. It says left bound. Okay, see my cursor's kind of flashing on there? So if I want it to find this point right there, the calculator is asking you, because there's more than one 0 on your graph, right? So it's like, which one do you want to find? So I need to tell it to the left or below the x-axis, and then it'll say right or technically above the x-axis. I have to say, look in between here and here and tell me where that answer is. Okay, that's what it's asking for. It needs direction. Where do you want me to look? So right now, is my cursor technically to the left or below my x-axis? Yep, so hit enter. And then it says right bound. So you have your left and right arrows up here. So hit to the right until it goes where you want it to. And I just need to make sure now it's above the x-axis. And then hit enter. And the stupidest thing I've ever seen in my entire life will pop up on your calculator. Do you want to guess? If I wanted to guess, I wouldn't have put it in the calculator. I don't know why it asked that. For the life of me, I cannot tell you why it says that. So just hit enter again because it's stupid. So what does your calculator say right now? Uh-oh. You did something wrong. So hit second trace again. We'll just start it over. Second trace, option 2 for the 0. All right, so left bound, good. Hit enter. Hit the right arrow, so it says right bound, so I have to go above the x-axis. Above the x-axis. Keep hitting it until it goes up. There you go. Hit enter. Hit enter again on the guess. There you go. Now, guys, one thing I want you to notice is where's your cursor sitting on the calculator? Right where I need it. Do me a favor. Look at that. Because if you messed up somewhere, and like, which is what the first thing John did, he didn't move it one below and one above. So when he had hit enter on guess, his cursor was sitting way down here. And you're like, that's not what I wanted. Okay, just do it again. Second trace, go back through the steps again. So the cursor should move to where you wanted it to be. Okay, we okay with that? If it's not sitting where you want it, you did something wrong. Also, sometimes people mess up left bound, right bound, because depending on what the graph looks like, it could be above and below versus below and above. It just depends. But the nice thing about the calculator, if you do it backwards, it gives you an error. It's like, hey, stupid, you did it backwards. Okay, so go back and do it again to flip-flop it, okay? One above, one below, though, when you're doing the left and right bound. So it gives me 0.3 repeating. That's 1/3. All right, 1/3. There we go, 1/3. All right, so now do I have enough answers to get me to a quadratic? Yeah, I do. So now we can set up our synthetic. Are we missing any terms first? No. Okay, so 3, 17, 30, 12, -8. And I'm going to go ahead and just use the -2 first because that's the first thing I have written down. And then we drop down the 3. A couple of you have a tendency to drop down other things than that number. Right, Jonas? All right, so let's go through our synthetic. So we multiply and then add. Multiply is -22. Add is 8. Multiply, add, -4. Multiply and add. Okay, so it's a nice confirmation for you too that it did in fact work because you got the 0 at the end. So right now I'm sitting at an x cubed, right? Because I did it once. I'm gonna do it again. Now, could I use the -2 again? No, because does that answer show up twice? Did it bounce? No, it didn't. So I have 1/3. It's not so bad. So what's 1/3 of 3? Okay, add those. What's a third of 12? Add. What's a third of 12? 0. That wasn't so bad. Again, if you're like, I hate fractions, use your calculator. Type them in. It's okay. All right, so I started x to the 4th. I did it synthetic twice. I'm down to an x squared. So let's put our x's back in. 3x squared plus 12x plus 12 equals 0. I know that's my remainder, but I'm lazy. I don't want to rewrite. So equals 0. All right. GCF, good. We can try to solve this. So take out a 3. So x squared plus 4x plus 4. Oh, very nice. This is one time, though, I will write it out so people can see it factored, but you are right. All right, so if we factors x plus 2 and x plus 2. Yep, because the question, I'm finding all the zeros. So we had found earlier -2, 1/3, -2 and -2. No, because that would imply -8. Yeah, so you have to actually list it out. Now, wait a minute. Didn't we say that we thought the other two answers were imaginary because it didn't cross?
Yeah, but we were wrong.
We were wrong because what actually happened? -2 showed up 3 times. Do you recognize that, though, by looking at the graph? No. Unfortunately, you can't tell that. All right. Questions on that one? Are we doing okay? It's kind of fun, though, isn't it? Like, the calculator helps you find those missing ones. You've missed a lot, too. All right. Let's look at the next one. Ooh, how many answers is this one going to have? 5. So what am I hoping for when I look at the graph? How many am I hoping to at least see? I'm hoping for at least 3. Because if I don't have at least 3, I'm in trouble. Yeah. All right, so let's go to the graphing calculator, because without that, it's a long, tedious process, which I don't want to do. All right, so let's go ahead and graph this bad boy. Give me an hour, because mine takes forever to graph up here. How are you? Okay. Did you get a funky graph? How'd our graphs turn out? Did we get at least 3 like we hoped? Nice. So what do we think the answers are by looking at that? 3 negative ones? Good. -1, -1, 2. Should we confirm just to make sure? Yeah. Second graph pulls up that table. -1, 0, 2, 0. So they are my zeros. So it did work out. Okay. So that's good. I found 3, which is what I said I needed. So we said -1, -1, and 2. All right, so what's my next step? Synthetic, because I haven't found all 5.
Since we have to do different ones, can we just like not square the problem, but like
Write it as -1 quantity squared. That implies +1. Yeah, no, we can't. And I appreciate the laziness trying to come out of you guys. I really do. I appreciate that. But in this case, we can't. I appreciate it, see? That's why this class is the best, right? The teacher lets you be lazy and appreciates it. All right. I know, right? All right, so I'm going to just go with -1 to start with. And we'll do our synthetic. So multiply, get -1, add, -5. Multiply gives me a +5. Add 9. Multiply, -9. Add 1. Multiply, -1. Add, -14. multiply 14, add 0. I know, I'm sorry. Oh, he doesn't want to be moved. Get out of the way. He really did not want to be moved. I know, I'm sorry. I stuck him right in the middle of your page. But he's cute. All right, so then I used the -1. I'm going to go -1 again because that answer did show up twice. Multiply, add, multiply, add, multiply, add, multiply, add. Yay. Yeah, let me do it again. I'm sorry. A little bit. I mean, I gave you paper. If you don't like it, get out your own paper. All right, so multiply, add, multiply, add, multiply, add. Whew. Yes, sir? Yes. All right, so we started x to the 5th. I did synthetic 3 times, so I'm down to an x squared. 5 minus 3. So x squared minus 4x plus 7 equals 0. No, you're fine. I'm just trying to get more page space. Oh, you're right. That doesn't factor. Square root method? Nope, I got a B term. Quadratic formula, or you can complete the square if you want. I will. I won't. That's never my choice. The shortcut only works for what? The cubes. And this was not a sum of difference of cubes, so don't use the shortcut. That's only for that type. Yeah, for me to finish solving, I'm going to have to go with the quadratic formula. So -b plus or minus square root b squared minus 4 times a times c all over 2 times a. What do you mean? I said it just as I wrote it.
I was writing out like the letters.
Oh, not the actual numbers. All right, so then we have to clean up underneath the radical. So we get 4 plus or minus radical. What's underneath there? 16. Is it -12? Whoa, whoa, whoa. At this step, am I ready to simplify? I got to take the I out, and I have to do my factor tree. Okay, that's going to give me 4 plus or minus 2i radical 3 all over 2. Now I can divide all 3 numbers by 2, right? All 3. It's going to give me 2 plus or minus I radical 3 over 1, which I don't really have to. I don't need. Does it surprise you that those last 2 answers are imaginary? It shouldn't, because when I looked at the graph, it only crossed and gave me 3 answers, which means the other 2 probably imaginary, or one of those answers showed up 3 times, which in this case it didn't. All right, so I had 2 plus or minus I radical 3. I had -1, -1, and 2. For grading purposes, if you put them all in one line for me, it's a lot faster than me searching all over your page for them. Yes, and circling them. Oh my gosh, yes. Some of your guys' work is all over, which I appreciate you showing your work, but then I can't find your answers. Oh, yeah. Of course it was. I know, everybody's tired today. Sure. Ready? All right. So find all the zeros of this one. Now, when you type it in the calculator, do you have to put in the missing pieces? No. The calculator's smart enough. You can just type it in exactly how you see it. Whoa, I should probably clear that first, huh? Oh, why do I keep hitting the wrong button? There we go. How many answers should this problem have? Should have 4. Wait a minute. You said it should have 4 answers? How many do you see?
Because it bounces, so it wouldn't be 2, so it would be -2, -2, and then 1, 3.
All right, go to the table to confirm. -2, 1, 3, they all sound good. So do I have to do synthetic? No. -1, wait, was it -1? -2? I totally forgot when I went away from it. 1. So do I have to do synthetic at all? No, I found all my answers just by looking at the graph, and I'm good. Moving on. Yeah, maybe 1. We found them all, yeah, just by looking at the graph. Sometimes that happens. Yeah, we looked at the table then to confirm that we saw them. I will make sure that you have to have your graphing calculator. All right, so let's look at this one. So I obviously can't factor that, right? There's 5 terms. So let's go to my graphing calculator. Let's type it in. Nope. I used to have a class that like half the class would seriously sit in like this area right here. They'd sit right around me. I mean, I don't care, but that's like where they were comfortable. They like to sit real close to the boards. They all just kind of sat around here together. Doesn't bother me as long as you're working. I don't care. On Halloween. It's not Halloween yet. Hi, Mr. Kurtz. How are you? Aw, he missed the brain break.
I know.
I wonder.
Somebody give me a chair so I don't fall off one of these things.
There's a chair right here. Would you like to sit? There's a chair.
You don't want to sit on the ball?
I don't know. I mean, it might be a little entertaining to watch Mr. Kurtz sit on the ball. Oh, he is going to try the ball. Lily, catch him if he falls off, okay? He's like, I'm good.
Sorry to distract.
You're fine. We like to get off task once in a while, don't we? All right, so go back to the original problem. How many answers is this problem going to have? How many did you find in the graph? Do either of these bounce? No. So what are we looking at? -2 and 1? How do you confirm? Table. So second graph brings up your table. -2, 0, 1, 0. So we know those are good? All right. Now I just forgot what I just said. What was it? -2 and 1. 0? Did it cross 0? No, that one's no good. Okay, so what do we do next? I found 2 of the answers. How many are missing? 2. I've used synthetic. What does it mean about the other 2 answers? They're probably imaginary. All right, so are we missing anything before we set up synthetic? All right, so 1, 1, 2, 4, -8. Does it matter which answer I go with first? Which one do you guys want to use? All right, so let's use the -2. Drop down the first number, and we multiply, add, multiply, add. Basic math's hard, I know. Multiply, add, multiply, add. If I get 0 as a remainder, what's that mean? That means I did it right. Yeah, I did it right. I got 0 for remainder. It means it was a factor. All right, so I started x to the fourth. I did synthetic once. I'm sitting at, what am I sitting at right now? X cubed. All right, so I do have another answer though. Let's go again using the 1. I'm hot. All right, so again, multiply, add. All right, here's the hard math. Multiply, add. Oh, good. Multiply, add. All right, we're good. So I started x to the fourth. I did synthetic twice. I'm down to an x squared. So let's put our x's back in. X squared plus 0x plus 4 equals 0. Yes. Yep, that's why we just kind of keep building. Remember, we can be lazy, right, and not rewrite. So the 0x, do I need that? Nope, so we're going to cross that out. And I can use the square root methods. Subtract the 4. You guys are on it today. Plus or minus 2i plus 2, negative 2, and 1. No. How are we feeling about all this? We're good? Can we do one more together? Of course we can. How many answers will this next one have? It's going to have 4. All right, you guys go ahead and graph it. I'll graph it up here. Can we get lucky and all 4 of them be on there? It's possible. Is it probable? Aw. You saying I challenge you too much?
Yeah.
Is it a good one? What do you mean no? So are any of my answers imaginary? None of them are imaginary. Okay. So what do we know about the answer in the middle of that? It bounces, which means what? Shows up twice. So this answer shows up nice, but what's the problem? Yeah, none of them are pretty. Uh-oh. Okay, so none are pretty. How many answers do I have to have in order to do my synthetic? I'm going to need at least 2, right? It's x to the fourth. If I have at least 2, I can get it to quadratic, which then I can have other options. So what would be the easiest one to find first so that I get 2 of them right away? The one that bounces. Yeah, if I can find the one that bounces, then this is going to work. Okay. Do you guys remember what buttons to hit to get it to calculate? Yeah. Second trace, because they calculate. And which one am I tracing for? 0. So option number 2. No, well, hold on. We got to watch where that cursor is. Now, normally, like we talked, it had to be one below and one above. But does my graph ever go above for the answer I'm trying to find? Good. So I truly want left and right this time. So right now, is my cursor sitting to the left of what I want? No. So let's hit our left arrow. And again, yours may have popped up in a different spot than mine. But hit the left arrow so that it's just somewhere to the left of that point. Hit enter. And then it says right bound. Have to go to the right. And hit enter. And it says, do you want to guess? Do you guys want to guess? No, if I wanted to guess, I wouldn't use the calculator. Just hit enter again. All right. Now yours, again, might look slightly different than mine. It might look slightly different. Now, looking at where it is, double check where your cursor is. Is it sitting where you wanted it to be? Might not see it because is it sitting? Mine actually, I can't hardly see it either. All right. Does anyone have negative 0.4999999? Okay. Negative 0.500001? Somebody have a 1 on the end? A 3 on the end? Okay. Now, this calculator is calculating things based on like the pixels in that screen. How high quality is this? Is it great? No, it's not great. It is. That's negative 0.5. Yeah, if you see a bunch of the zeros and the 1, the 2, the 3, you get the 0.4, 9999999. It's, yeah. Now, granted, if you got all kinds of digits in there, don't write, you did something wrong or it's not a pretty answer, okay? If it said quit, you did your left and right wrong. Yeah. Which is a nice thing. It's like the calculator saying, you know, you did something wrong, go back and look at it again. Now, when you did your left and right bound, Tara, you have to make sure one of them's to the left of that point that we want and one of them's to the right of that point. But it can't be to the left so that it went back up the other side of the curve, because then it's confused. So give it another try. Let me know if it doesn't work this time. All right, so are you guys okay that it's negative half? Okay. And what do we know about the answer negative half? It shows up twice. Okay. So x equals negative half. All right, you guys go ahead and try doing synthetic with that while I help Tara with that. Okay, so let's set up our synthetic. Was anything missing for the synthetic that we needed any zeros? No, okay. So we have 4, 4, negative 11, negative 12, negative 3. If you lost a negative sign, right, Dakota, it makes a world of, ugh, right? It does not work. All right, and then some of you, I caught a couple of you, it's negative half. Some of you had a positive half written down there. All right, so drop the first one. What is negative half of 4? Okay, then we add negative half of 2. Negative 1. Add negative half of negative 12. Add negative half of negative 6. And then that gives me my 0. I know, basic math's hard. It's always that little negative sign, that teeny tiny little line makes a world of difference. Now, what do we know about negative half? It showed up twice because the graph bounced. So let's go again with the negative half. Negative half of 4? Negative 2. Add and we get 0. What's negative half of nothing? 0. And then we add negative half of negative 12. And there's my 0. All right, so I started x to the 4th. I did synthetic twice, so I'm down to an x squared. So 4x squared plus 0x minus 12 equals 0. What don't I need? Yeah, if you have a 0 anything in there, it kind of gets in your way when you're thinking about solving. So really I have 4x squared minus 12. Okay, we got some options. Let's talk about our options, okay? Option 1 is you can take out a GCF. Jonas? That's what most people would probably do. The easier option is just to add the 12. So 4x squared equals 12. And then just divide by the 4. Could you have taken out the GCF first? You could have. So x squared equals 3. Negative half, negative half. Now, did we know that my answer would not be imaginary? Yes, how did you know that? Shows on the graph. Yeah, if we can see it, we see the 4 answers on there, but the other 2 were not pretty. If I had tried to do like the calculating, the left and right bound, make my calculator find those other 2, would I have recognized radical 3? What is radical 3? Type that in. What's the square root of 3? Blah, 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 keeps going. We're not going to recognize that, right? If it traces that, you're going to be like, I don't know what that is. But look at this. Is that where, you guys, we just solved for plus or minus. Positive 1.73, does that make sense? Negative 1.73? It makes sense. Are radicals always going to come in pairs as well? Yeah, because anytime you take the square root, it's plus or minus. Yeah. So the i's come in pairs, the radicals come in pairs. Okay? How are we feeling? Good? All right. Now your homework for tonight, I'm going to give to you right now, because obviously to solve these, what do you need? Your graphing calculator. So what I want you guys to do, we have some time left. Use the rest of today. Get done what you can, and then tomorrow when you come in, the first half of class, I'm going to give you time to work on this and get the practice so you have the calculator. Okay? Now, obviously, some of you have your own graphing or you have the app on your phone. That's fine if you want to work on it. If not, that's okay. Just wait till tomorrow. I'll give you time in class.